Okay, guys. So now we have kept our applications. I mean, we have built our applications. We have pushed them in the registry. Now we have a registry, and it consists of all the container images that our application has. Right. I mean, the CoIT front and CoIT backend, and Java, Python. Right. For all the application now, the container images have been created, and it is stored inside a registry, and that is great. And because it's time to run your applications, and that's what we are going to worry about next. How you will run the applications. Yes, you already know. If you have a computer, if you have a machine, and if the machine has Docker installed in it, you can simply execute the Docker run command. Docker run followed by the image name. The image get downloaded locally, and then the container will start running inside the machine. The Docker run command, right? You are already familiar with Docker run command. So Docker run command will create a container. Of course, that's great. It's a good thing. Docker run command create container, and if you want to create multiple container, you can execute the Docker run command multiple times, and container get created all over, right? So that's a good thing. That's how you can run the containers using Docker. But is this the best way to run a container? The answer is no. That is not how you should be running the containers. And I will, on a high level, I will tell you how you should be running the containers, right? In order to run the container, first of all, you need a number of machine, because in a company, in a real company, you would be running a lot of containers, maybe 10,000 containers, maybe running inside your project, inside your production environment. And these containers has to run in a number of machine, not on a single machine, right? It's not possible that you can use a single machine to run all the workload, because there will be a lot of workload that you have to run for your project, different applications like front end, Java or Python. There are various applications. For all these applications, we have to run different containers. So it's not a big deal. A team has to manually sit in front of a computer and then run the containers using the Docker run command. It's not a good thing. It's not very straightforward, and it's not very easy either. And also, you are running a lot of containers. You want to run assume sometimes you want to run multiple containers. For example, the CoIT frontend container, you want to run 3. CoIT, Java container, you want to run 3, and Python container also. Assume you want to run 3 of them, and all these containers want to talk to each other, right? There should be some kind of communication that has to happen between the container. The front end want to speak to the backend, Java want to speak to the Python, and then there are 3 containers. So you want to make sure that all the container has a proper load balancing in place. In other words, somebody want to speak to CoIT front-end application, then they should be speaking to one entry point, right? And in your laptop, you are browsing, and assume you want to run 3 or 4 or 10 containers of the CoIT front-end application. Your browser should be speaking to a single point, and that single point will be distributing the traffic to one of the backend containers. So if 10,000 people are browsing for your website, and if there are 10 CoIT front-end container that you are running, you should make sure that 1,000 people go to one container, 1,000 people go to the next container, like that. Each 10 container will get 1,000 requests each. So you want to make sure of such kind of things, doing a proper load balancing. There should be a proper entry point that happens between your containers. So there are a bunch of things that you need to take care. And also, if the container ever goes down, it should be restarted automatically. That is important, right? You are running some 10 containers of your front-end applications. You want the container to be restarted automatically if they ever goes down. And you most preferably, you might want to put the containers across different machines, rather than putting all the container in the same machine, right? You can run multiple containers in the same machine, but think about the front-end application. If the machine goes down, then and all the containers are placed on one machine, and if that machine goes down, then the application goes down, right? So you should make sure that the container are running on different machines. Even if one machine goes down, there are other two machines or other two containers that is serving your customers. So you want to make sure of that. And like that, there are a number of things that you need to make sure that it works for your applications, right? So that's the idea. And also, if the containers are running in different places, for example, front end is running somewhere and back end is running somewhere, you have many machines in your company, and all the machines, different machines are running different containers, and they want to talk to each other. The front end want to talk to back end want to talk to Python. So there are a lot of communication that has to happen between the containers. So there should be some proper networking between the machines. So first of all, you need a number of machine instead of one machine. So all these requirements are there when it comes to a production environment. A production environment inside a company is much more complicated because a lot of traffic is coming, lots of issues are coming, lots of sometimes the machine can crash. You have to do a proper monitoring, and you should restart the containers if they goes down. There are a bunch of things that you need to do, and you should do it in the right manner, and your infrastructure should support such kind of things, right? So that is where Docker would become inefficient to run your containers, and that is where Kubernetes come into picture. Kubernetes is a container orchestration tool, and that tool, it's a software that you can install. It's not a single software. It is developed as a combination of a number of small software components, and together it can do a lot of things. Kubernetes can do a lot of things. You can create a number of machines. It could be in the AWS cloud or anywhere in your premise, right? And you can create a number of machines, and you can run a Kubernetes inside those machines. And then that machines will work together like a single cluster, and then you can start running your containers into that machine. So that is what you can do. You can actually set up Kubernetes on a bunch of machine that you have in your company, and then that set of machine will mark as a single machine. You can forget about the individual machine. Instead of working as individual machine, Kubernetes will work as a single piece software that can run your applications, and that is the idea. And you can forget about the individual machines. You can actually focus only on doing some development on top of Kubernetes. For example, what Kubernetes will do is you can create a cluster using Kubernetes, and in the background, what Kubernetes does is there are a bunch of machine where different softwares will run Kubernetes software, various softwares that is needed for the internal management of Kubernetes. So these softwares will run across a bunch of machines, and then finally, as a DevOps engineer, you would get a cluster, and into that cluster you can start creating your containers without worrying about what is the actual machine in behind the screen that is running your container. Maybe some of the container are running here, some of the container are running here, some of the container are running here. And as a DevOps engineer, I don't really have to worry about different machines. Instead, I would simply, whatever container that I want to run, I would run them inside the Kubernetes cluster, and I will let Kubernetes choose which machine to run the container, right? Kubernetes can manage these machines internally without you having to do it directly. What Kubernetes does is it will watch each and every machine inside the cluster, figure out which machine has lot of CPU, lot of memory, which machine have free space for a container to be created. So as a DevOps engineer, you ask the Kubernetes that, I want some 10 container to be created of the front end application. What Kubernetes does is it will check which machine has enough CPU and memory and create different containers across various machines that is there inside the cluster. You as a DevOps engineer don't have to worry about the machine or scheduling the containers across various machines. Kubernetes does that. Kubernetes do the best decision by analyzing the machines and then taking care of the container creation. And that is something that Kubernetes will do automatically. You can just tell Kubernetes that this is what I want. I want 10 containers to be running. I want 5 containers to be running for the Java application. I want 15 containers to be running for the Python applications. I can just give that instructions to the Kubernetes, and Kubernetes internally takes care of the rest of the things. Not only the machine management, a lot other things also Kubernetes will take care. I can tell Kubernetes that I want my container to be restarted automatically if the container ever fails. Or I can tell Kubernetes that at the time of creating the container, you set some environmental variable inside the container. Or I can tell Kubernetes that no, if every container that I create, it should be given some kind of label. And this is how the container will talk to each other. If the Java container want to speak to Python container, they can actually speak to the Python service that you create inside the cluster. So you can give different instructions how they can talk to each other, how they should run in case of a failure, how it should be managed, and then where it should be scheduled. Right, a lot of instructions you can give to Kubernetes, and Kubernetes takes care of the rest. And what Kubernetes also does is Kubernetes will keep a copy of the desired state. So you as a DevOps engineer, you will define the desired state. This is where you will define everything what you want, how many containers to run, which Docker image to use, and what environmental variable to pass, and then how it should be restarted. Should it restart automatically if it failure, or it should be always restarted? There are a number of instructions that you write down as a DevOps engineer, and in other words, you can call it the desired state of the cluster. And then sometimes the actual state of the cluster can vary from the desired state. For example, a machine can fail, a network can fail, a container can crash, right? A lot of things can happen inside the machines. Maybe a machine itself get crashed, or your application get crashed inside the container. So such kind of things can happen in the actual state. And one best thing that Kubernetes have is that Kubernetes have some controllers, right? Controllers inside. And what this controllers does is it will keep watching the desired state, and it will keep comparing the desired state with the actual state. And any problem happen, for example, a container got crashed, then Kubernetes will notice that, hey, the actual state is different than the desired state. Then Kubernetes will take action. There are a number of controllers. It's called controllers. There are a number of controllers inside Kubernetes, and they will correct the problem. They will keep checking the desired state, and they will keep comparing the desired state with the actual state. And at any point, the actual state has changed. Kubernetes will automatically check the desired state, figure that okay, this is not. It should be the total number of Python containers should be 3. It should not be 2. So if Kubernetes immediately recognize, some controllers in Kubernetes immediately recognize that it should be as per desired state, 3 Python containers should be running, but the actual state only 2 are running. One got stopped due to some reason. So what it does is it creates some extra container. So these things will happen. Kubernetes will do such kind of things automatically. Or in the desired state, it would say, CoIT front-end image is v12. So, and assume, right, you can change the desired state. You decided that you want to release the latest version of your software to your customer. So you decided that currently, I have the backend application, the Java application that is running v11. So I have a container image that I created called v11, and from the v11, Kubernetes created all the 3 containers of Java. And at some point, I decided that I want to release the latest version of my software to the Kubernetes. I can come here and I can change this desired state to v12. So basically, I'm giving an instruction to Kubernetes that I want my Java containers to run v12 version. So I will put a v12 image inside the inside hub.docker.com, inside the registry, then I would tell Kubernetes that, hey, use this image instead of v11. Then Kubernetes will again check the actual state, says it's currently it is v11, but the desired state has changed, it's v12. Then again the Kubernetes controllers will take the action. It will delete all the v11 containers and they will be replaced with v12 containers, right? So the new container get created from the latest image. So this way it automatically manage the stuff, and your only responsibility would be to define the desired state. As a DevOps engineer, this is what you will do. You write the desired state and you write them inside a file. Inside a file you can write this desired state, and then you can submit that file to the Kubernetes cluster, and then that would become the desired state of your cluster, and Kubernetes does the rest of the things, right? Any problem happened, or due to any reason machine crashed, or network connectivity problem happened, or some application crashed in the container, any problem that ever happens, Kubernetes will compare the desired state with the actual state, understand that, okay, there is a change, then let's fix it. Or you want to make some change to the cluster, for example, you want to upgrade your applications, you will make changes to the desired state and then let Kubernetes do the rest of the job. And remember, if you are changing the application image to v12, first of all, you should push v12 image into hub.docker.com. That is obvious, right? That is obvious. If your company decided to deploy v12 application to the cluster, first of all, v12 Docker image should be put inside the registry. Then you can tell Kubernetes that this is the image that you want to use. So you would specify the image name as CoIT learning, right? CoIT learning / of course, you should specify the full name, which in our case is CoIT learning / CoIT backend, right? So basically, this is what Kubernetes is capable to do. It can let you forget about the underlying machines. It can let you forget about a lot of operational complexities, and it gives you a single cluster that is very easy to manage just by using a number of files where you will define the desired state. So that's what Kubernetes is. It makes things very less complicated for you to manage your production. Not only production, whatever environment your company have, Kubernetes makes it easy for you, right? Because it manages many things for you. So you already know, inside my hub.docker.com, I have a bunch of containers. I have a bunch of container images available. CoIT backend 2, CoIT backend 1, CoIT frontend. V11 is the latest image I had pushed into this registry. And now I have a Kubernetes cluster also, which I didn't tell you where I created. So for now, you forget about it. Okay, just forget about it. I'll talk about it later. For now, I just want to demonstrate something to you, and I'm going to open my code, and I'm going to open a folder. You already have access to this folder. It is there in the GitHub. And now I'm going to show you something. I'm going to show you the CoIT frontend deployment.yaml. There is a file. It is a YAML file. YAML is the syntax that you use in order to write the Kubernetes manifest or the desired state. I talked about the desired state. That is where you write the instructions for Kubernetes. You specify how many replicas you want to run, how many containers you want to run. So assume in my case, I want to run total 3 containers or maybe 2 containers I want to run. Then I can specify some instructions such as what is the container image that I want to use. So in my case, I want to use this image CoIT learning / CoIT frontend v11. That is the image I had just pushed into hub.docker.com. So assume this is the image that I want to use at the time of creating the containers, and then request limits. I'm just going to comment out these lines. Let's not worry about them at the moment. Yeah, so just there are a bunch of instructions what I have written. in here. There are a bunch of instructions which I have written inside this file. I want to create two replicas and stuff. I'll talk about this file in detail. For now, what I'm going to do is I'm going to apply this file to a Kubernetes cluster that I have connected with my laptop. So now I am on my laptop. I'm not on my AWS machine. I am sitting on my laptop, and inside my laptop, I have kubectl. I have kubectl. Kubectl is a software which I can use to speak to the Kubernetes cluster. And yes, I also have a Kubernetes cluster. And this Kubernetes cluster may be sitting anywhere. It could be sitting in the Google Cloud. It could be sitting in the AWS Cloud. And assume this cluster is sitting somewhere in the cloud. And this is my laptop where I install kubectl, and kubectl is configured to talk to the Kubernetes cluster. This is something I had already done. Right? This is something I had already done before, which I didn't show you. So you just believe me that I have this set up in my laptop. I have my laptop, kubectl is installed on my laptop. I have a Kubernetes cluster sitting somewhere. It could be in the cloud, it could be in premise, it could be local, it could be anywhere. Right? Assume I have a cluster. And into this cluster now I want to deploy something. I want to apply the decide state. And I have written the decide state in a file. This is a file where I mentioned that two replicas of CoIT front-end application to be created from this image, which is available in hub.docker.com, and that is the instruction I want to give to my Kubernetes cluster. And let's see how do I do that. In order to do this, I will go to my laptop. In my laptop, I have a folder called. This is where I have kept this file where I have written the CoIT frontend deployment.yaml. This is the file which I am just demonstrating to you. CoIT frontend deployment YAML, and the file consists of the instructions. I want to create two containers, and this is the image from which I want to create it. Right? All these instructions are written down over here. Now I'm going to execute the command kubectl apply -f followed by the file name. That's all. That's all I'm doing. I just run one single command, kubectl apply -f, then the name of this file where I have written this instruction. This file is in my laptop. Now I am submitting this file to the Kubernetes cluster using the kubectl command. That's what I'm doing. Or in other words, I am specifying the decide state of the cluster. So I told you it's a game between the decide state and the actual state. So I am defining basically the decide state. The decide state says this is the Docker image that I want to use, right? What is that? This is the container image that I want to use, and from this image I want to create two replicas, two containers I want to create, and this is the image. And that image I had already placed in hub.docker.com. Remember, right? We have already pushed this image into hub.docker.com. The CoIT frontend v11 image is already there. So that you are asking Kubernetes cluster to take that image and create two containers. Replicas equal to 2 means I want to create two containers. And there are bunch of other instruction also I am giving, which I will talk about later. So for now, if I execute this command on my laptop, kubectl apply -f, then I am setting the decide state. These are the instructions I'm giving to the cluster, and it will do the rest. So let's see what happens. So it says the deployment got created, right, and stuff, right? I mean, but yeah, whatever deployment or whatever, I'll tell you what is a deployment later. But yeah, deployment or whatever, this is the decide state right now in my cluster. I want two containers to be created from this image, and let's see what is going on inside the cluster now. And now I want to see, I am expecting that now two containers are getting created inside the cluster, and in order to see that, there's a kubectl command. So whatever thing that you want to do in the Kubernetes cluster, kubectl is your friend. You want to see the list of containers, you want to see the list of services, you want to see the list of machines, you want to apply something, right? So kubectl is the command. So within kubectl there are various commands. There's a command called get ports. Get ports is the command that you can run to see the list of pods or containers. I mean, for now, you just assume containers. So I want to see the list of containers inside the cluster. We can use this command kubectl get pods, and yes, it seems like it's working, right? Two containers got created, and these are the name of the containers. Pods, actually they are not containers, it's called pod, but yeah, they are same. For now you assume a container and a pod are the same. So the containers are properly running inside the Kubernetes cluster. It's working, right? So previously there was no containers, right? And then I have specified the decide state. The decide state is this, and the actual state, there are no containers right now, right? It's a, in my Kubernetes cluster, it's zero containers, right? That is the current state. Now I set the decide state to this. So what happened is two container got created, and now my decide current state has become the decide state. Now my current state has become the decide state. Great. So that's what happens every time I set my desired state using kubectl apply. That is what Kubernetes will internally do. And this is nice, right? Every time I want to change something, I will make the change in the code. In my laptop, I will write something. I would specify, I want to release a new version. I would mention it will be v12. So anytime I want to change the decide state, I will change the file, and then I will run the kubectl apply command, and then it would set the decide state to v12, right? Assume, let me do that, right? So instead of v11, I want to use something called latest. So assume I have a image called latest. And so I'm going to change the state, decide state, I'm going to change to latest. Now what will happen if I run the kubectl apply again? If I run the kubectl apply again, so what happens is the decide state has changed, right? It is now says latest. So then Kubernetes will do some internal checking about the actual state. As per the actual state, it's v11. So there's a change that is going on. And now you run the command kubectl get port. So you can see something. You can see that now it is creating two additional containers, and the all containers are now being terminated. All those containers which have been created before, they will be terminated, and a new two containers will get created inside the Kubernetes cluster. And that is what it will that is what will happen internally, because the desired state has changed. The new desired state says latest image, then it realized that over here it's running v11, so it will change that to desired state. So what that means is currently all these images are running v11, the old version, and then Kubernetes will also check, is there any possibility to make changes to the existing containers. So it depends on the change what you made. So in your case, the change what you made is that you change the image itself. You change the image to some other image. So Kubernetes cannot update the running containers if you change the image. So what Kubernetes will do in this case is it will create two new containers and delete the old container, because image cannot be updated in the runtime. So this is what Kubernetes will do. It creates some new container. It won't delete the old container until the new ones are created. So Kubernetes automatically make sure that there is no downtime. Kubernetes will wait for a new container to get created before deleting the old container. That is why when you notice the status, even after 23 seconds, the containers are yet to be created. So, and that is the reason the old two containers are not terminated yet. It's waiting for the new container to come up. And once the new container come up, the old container get terminated. So let's see what is the status now. And yes, now the new containers has come up and the old containers have been deleted permanently. So this way, every time you want to make some update as a DevOps engineer, you will write inside your YAML file, make the changes and set the desired state using the command kubectl apply. kubectl is the command that you can use to talk to the cluster and apply your changes to the cluster. And then you are setting the decide state, and then Kubernetes internally compare the decide state with the actual state and then make the necessary actions. And in order to do such kind of jobs inside the cluster, there are something called controllers. Controllers are some piece of softwares inside the Kubernetes cluster, some internal Kubernetes softwares. That is the one who make these transitions, bringing the actual state to the decide state. It will keep checking the decide state, compare it with the actual state, and then make the necessary changes to make actual state to the decide state, bring actual state to the decide state. It is some controllers which are different pieces of code that run inside the Kubernetes cluster. That will I will talk about controllers a little bit later when we talk about Kubernetes architecture. So that is the idea. This is how you work when you are using Kubernetes. You as a DevOps engineer will write the code. It's simple code. You just need to follow the syntax. That's it. I'll talk about that later. But yeah, this is how you work. You will make the changes in the code, and then you will submit your decide state, and then Kubernetes make the necessary changes to convert the decide state to convert the actual state to the decide state. And that is exactly what happens, right? You don't directly log into any machines. You won't directly work on any containers. You work on your laptop, you make the code change, and whenever you want to change something, you want to release the latest version of the software, or you want to delete a container, you want to create a container, you want to do anything, you want to see the list of containers, you want to see the list of services, whatever that you want to see or whatever you want to apply, you will just use a command, make the code change in the YAML file, and do the kubectl command to get things done. Okay, so let's talk about what is a cluster. So a cluster, as you might have understood, it's a combination of machine. When I say cluster, a simple meaning of a cluster is it consists of a number of machines. It could be AWS machines, Google Cloud machines, or some machines. It could be your on-premise machines, any machines, or a bunch of machines work together to form a cluster, and different software components will run inside each of these machines, and then those softwares will coordinate the functioning of the cluster, some way, what is the status of the cluster, how the current state of the cluster, and then a number of the coordination need to happen for a cluster to work properly. And then all the machines who is part of the cluster, they run various software components which takes care of the cluster administration and cluster management, right? That's the point. Great. So what we have to do is, sorry guys, yeah. So what we do is, when you want to create a cluster, you can either create the cluster yourself, you can create a bunch of machine, and inside those machines you can set up softwares, you can set up various softwares, such as number of software that Kubernetes provide, and all of them, Kubernetes is a open source software, free software. Anyone in the world can get the Kubernetes code or get the Kubernetes software, install them across a bunch of machines. And if you want to set up a cluster yourself, you can set up the cluster yourself. It's not very difficult, but comparatively difficult than asking your cloud provider to create a cluster for you, right? So you have to do everything from the scratch. You have to take care of the network connectivity between the machine, because various containers run inside various machines. They want to talk to each other, so you have to take care of the network connectivity. You have to take care of the storage, right? If the machine get deleted, what will happen to the data? So you should have some permanent storage where you want to store your important data. There are a bunch of things that you need to take care. If you are setting up the cluster all by yourself, or most of the company will create the clusters inside the cloud, inside the favorite cloud provider, Google Cloud, AWS Cloud, or Microsoft Azure. And there you can create a cluster just by clicking some button. You can mention, I need a cluster. How many machines do you want? I need some 6 machines. You can choose, right? Then you can click next. They will ask you how much storage you want. I need this much storage. Click next, and then I click on create button, and a cluster become ready immediately. So that is probably the easiest and best options to run a Kubernetes cluster today. And so whatever it is, whether it is your own Kubernetes cluster that you set up from the scratch, or it is a cluster created by your cloud provider, it has the same, more or less, it has the same architectural structure. So I will talk about that, right? We'll talk about that. So mainly, you can split Kubernetes into two things, a Kubernetes cluster into two things, the control plane nodes and the worker nodes. So when I say control plane, basically in order to manage the cluster, there are a number of software that need to run, right? In order to manage a Kubernetes cluster, there should be some internal management software that should run, right? So they are called management softwares, or they are or the machines which run these softwares are called control plane nodes. So every Kubernetes cluster in the world, whether it is cloud or whether it is on-premise, there will be a control plane, and this control plane node should be running various software. There are a bunch of software that Kubernetes has that include. I will write it down. I will list it down. Various softwares that run inside the Kubernetes cluster include. The most important one is an API server. An API server, that is, you can say the brain of the Kubernetes cluster. That is then there is a scheduler. Again, a bit complicated software. And then there are various softwares available, right? There are controller managers. Controller manager is another software. Then there is a cloud controller manager, that is another software. There are a bunch of software, and these softwares are used for the managemental purpose, and you run the software, and there should be some database where you want to store the state, the desired state, the actual state, all the state you want to store them inside a database. So there will be an HT database, and also things like that, right? So that's the point. And now what we have to do is we have to run all this. In order, the first step of creating the cluster is obviously to set up the control plane. Control plane can be installed on a bunch of machine which are called control plane nodes, and these are the various software that you want to run inside those machines, right? So you will do that, and that is how you initially set up a cluster. All the software components should be running. And again, like I said, if it is your own cluster, you would do this. Otherwise, your cloud provider would do this. At the end, you should have a control plane, that is a number of machines running different control plane components, right? And then those machines are used only for that purpose. Your containers, right? In my case, I have created some containers, CoIT front-end container. I created 2 of them, and your workload won't be running in these machines. These machines are used only for the management purpose, or to run the control plane components only. These machines will be used, and then your containers, they mostly run inside the worker nodes. So the worker node responsibility is to provide enough CPU memory power, right, to run your workloads, whatever workload that you have, CoIT front application, CoIT backend application, whatever container that you ever want to run inside the Kubernetes cluster. All those containers are running inside the worker nodes. And that's the point. And then similarly over here, these are also containers actually. Now you assume, so how API surveys are running? Are they installed directly into these machines? No, they are running inside the machine. They are also containers. API server is a container, and then scheduler is a container. So just like how your application will run in the worker node as containers, that is how these applications run inside the control plane nodes. So they are also containers, but you don't care. I mean, these are not managed by you. Of course, I mean, if it is a self-managed cluster, you have to take care of their installations and stuff. Otherwise, the control plane components, you don't care too much because Kubernetes internally manages them, or your cloud provider set up them, and your cloud provider manage the control plane completely if you are running your Kubernetes cluster in the cloud. And yes, it is your responsibility to manage the worker nodes and then running the containers inside the Kubernetes cluster. And if you are using cloud, maybe these machines are also partially managed by the cloud provider. What that means is, in AWS, you have EC2 machines. In Google Cloud, they have virtual machine. In Azure, there is virtual machine. So every cloud provider has a virtual machine service. AWS EC2 is a virtual machine service. And they already have machines, right? They already have machines. They are EC2 machines. So you don't have to worry about the machines. AWS will, whenever needed, AWS create or delete the machine for you. So most of the time, the machine creation, etc., are managed by the cloud provider themselves, and then monitoring the machines, watching the machines, then looking for the errors. So you also have some responsibility. So don't assume that AWS takes care of all the machines. These are machines that you can see once you log into the cloud. You can even log into the machine if you want, and you can manage them. So AWS will, whatever cloud provider that you're using, you will get access to the worker nodes. You won't get access to the control plane nodes that is completely 100% managed by the cloud provider, but the worker node is partially managed by you and partially managed by the cloud provider. And running the containers, it's your responsibility, and that is where you will be writing these YAML files, making the changes, and then applying the changes to the cluster. And that a DevOps engineer will do from his laptop by using the kubectl command. So kubectl is a command that will speak to Kubernetes cluster. Technically, it will speak to the API server of the Kubernetes cluster and get things done. So every time I run the kubectl apply command or kubectl get pod command or whatever kubectl command that I am executing, as you already know, my laptop is actually speaking to the Kubernetes cluster. And which particular software component in the Kubernetes cluster? It's actually the API server. So API server is the one who receive all the requests coming from all the places. It's not only kubectl. In our particular case, you have seen kubectl. It is not only, it does not has to be from a developer laptop. Sometimes a request can come from some application. Sometimes the request can come from some CI/CD system that your company have. So there may be many people and many systems that want to speak to Kubernetes. They all speak to the API server. API server is the particular software which will listen to everyone. It listens to everyone. Whatever request coming in, it is the API server that receive the request and process the request. Great. So that is the responsibility of the API server. Listen to the request coming from kubectl, the request coming from, sometimes these machines will also be sending some request to the API server. It will ask the API server. It will keep updating the API server how much CPU it has free, how much memory it has free. So that information, some software that run inside the worker node will keep sending to the API server. So API server process that information, store that information in the HT database, and do such kind of things, right? So that's what API server is all about. You always talk to the API server. Anyone in the world who want to talk to a Kubernetes cluster, the particular component that they are speaking to is the API server. And then scheduler is the software within the Kubernetes cluster control plane that is responsible for deciding which machine the container should get created. CoIT front-end container, CoIT backend container, or whatever container that you try to create, they need to get created inside various machines. So Kubernetes has to first check the availability of the CPU and memory in each machine, which the machines will keep sending to the API server, and it will be stored in HT database. So the scheduler will check the status. It will check the S3 database, it will check bunch of other things, it will verify. No, it will make the decision on which machine the container need to get created. A DevOps engineer using kubectl will keep changing the instructions. I want to run 20 containers. So then 18, currently there are only 2 containers, now 18 container need to get created extra. So the scheduler will keep checking the current state, then it identify which machine has enough CPU and memory or space to host a new container get created in those machines. So it is the scheduler who takes care of such kind of things, scheduling and creating containers across the machines. That's great. Now the next thing is the controller manager. Controller manager is another software component that run inside the Kubernetes control plane nodes. And this controller manager takes care of the controllers. I talked about controllers, right? They are the smartest thing in Kubernetes. They keep checking the desired state, and they will convert the actual state into the desired state. Right? Controllers, that's what controllers do. They check the desired state. Any change that happened in the desired state, it will make changes to the actual state accordingly. Or any problem happened in the actual state, it will now the controller will fix the problem, because controller will continuously keep checking the desired state and keep comparing it with the actual state. If there is any difference ever happened, it will fix the problem immediately. So I will prove this to you. There's some controller right now. I'm not telling you what controller and stuff, but yeah, there's a controller, and currently I have containers running. I'm going to delete one of this container, and let's see what happens. The command is kubectl delete pod. So currently in my cluster, 2 containers are running. I'm going to delete one of the container, one pod I am deleting. This is the command I can use to delete the pod. Now one pod got deleted. One pod got deleted. Great. Now let's see how many pods are running. Actually, 2 are running. When I deleted this pod, somehow the pod got recreated. So who did that? So some controller inside the Kubernetes cluster did that. Actually, it is the deployment controller that does that. What it did is it identified that a pod got deleted. But what is your desired state? The desired state says replicas equal to 2. There should be 2 containers. But the actual state, only 1 container is running. The second container is deleted. So the actual state is 1, desired state is 2. What controller will do? It create a new container. And you can see 8 seconds ago, or in other words, immediately after I deleted the pod, a new pod got created immediately. So due to some accident, due to some CPU problem, memory problem, or my application get crashed, any pod get deleted, controller fix the problem automatically without you having to worry about it, right? Because controller just keep checking the desired state and the actual state, and if there is any difference, it will make the changes. Great. And HT, like I said, is used for storing the data, right? Storing the data. And then there is Cloud Controller Manager. That is actually an optional component. If you want, you can use it. So if you are using a cloud managed cluster, this component would be there, and it can internally speak to your cloud provider. Right? Sometimes you want to, not sometimes you want to create machines. These are machines from your cloud provider actually, whether it is a control plane node, whether it is worker node. These are the machines from the cloud provider. Or sometimes you want to create some storage devices in the cloud. Then you want these machines to talk to each other. So some network communication, some network need to get created in the cloud, and all these things Kubernetes can coordinate without having to worry about your cloud APIs. So this particular software within the Kubernetes cluster can internally speak to your cloud provider, create machines, delete machines, create network, delete network, create volumes, delete volumes, such kind of things. It can coordinate. It can talk to your cloud provider API and then get things done for you. So you as a DevOps engineer will keep writing the instructions, and then you don't have to worry about the cloud. this particular software will internally speak to the cloud. It will read your instructions, then it understand that some cloud resource need to get created or a new machine need to get created. Whatever you want to do, you write them in the instructions, and then this will internally speak to your cloud provider and get things done. So these many softwares run inside the control plane nodes. So when I say cluster, it is a combination of control plane nodes and also the worker nodes. So let's talk about the worker nodes, how they are working, right? So inside the worker nodes, your workload is running. The containers, whatever container that you create, they run inside your worker nodes. You already know that, right? That's great. And then apart from that, they also run some software. One software is Kubernetes, and then other software is Kubernetes. So two softwares are running inside every worker nodes. And again, these are internal management components of Kubernetes. Or what Kubernetes does is it runs in each and every machine in the Kubernetes cluster. Not only the worker node, they run in the master node also, control plane node also. And what these machines does is it will keep sending its status to the API server. Kubelet, that's the responsibility of Kubelet. Every few seconds, it will make a request to the API server, or it will send some data to the API server about the current status of the machine, how many containers the machine is currently running, what is the CPU status, what is the memory status, what is the peripheral storage state. So a number of information that the Kubernetes API server want to know, because that is the brain of the Kubernetes. You want to keep sending, updating the Kubernetes about the information about your machine. So that is automated by using Kubernetes. Kubernetes is a software that get installed automatically in every worker nodes, and it will keep sending the worker node data to the API server. And Kubernetes proxy is a networking software. Basically, it makes the internal communication between the container possible. So you have some container CoIT backend container here, and then you have CoIT backend CoIT Python container, right? Java container and Python container you are running across various machines. So how the container will talk to each other, the Kubernetes proxy, which runs inside each and every machine, enables such kind of communication. So that is why the Kubernetes proxy is another software which run across all the worker node inside your cluster. And remember this, if you are setting up a cluster all by yourself, it is your responsibility to install and configure the worker node machines, also install and configure the control plane as well as the worker node machines. But if you are using cloud, all these components are hidden from you. The cloud provider will have their own control plane, and then they won't even give you login access to that control plane. You can only focus on your worker nodes and your workload. So cloud, creating a Kubernetes cluster in the cloud is much convenient, and throughout our training we will be using the clusters from the cloud, not anything that we set up manually. And also, maybe sometimes we'll create some clusters locally, that is using some software. Otherwise, most of the time we will be working on the clusters that is in the cloud, right? That is how the Kubernetes architecture look like. And then kubectl is the software that you use, that we already discussed. And kubectl is internally, whenever you run the command kubectl get pod or kubectl apply -f, right? To apply a YAML file or setting the reside state. So all these things you just use the kubectl command to execute such kind of things. And kubectl internally speaks to the API server of the cluster, and the API server software along with a bunch of other software, they are running inside the control plane nodes. And if you are using cloud, the control plane nodes are not managed by you, it is managed by your cloud provider. You can just make sure that kubectl has the ability to speak to that control plane. Otherwise, you don't have to worry about the control plane. It is completely managed by your cloud provider. Great. So that's the idea. I'll talk about three kind of objects that you want to create inside the Kubernetes cluster: pods, services and deployments, pods, deployment and services. Okay. So a pod is technically, for now you just assume a pod is a container, but actually it's not. Right? Inside Kubernetes cluster, I have been calling it container. The actual term that I must use is pod. So a pod is basically a wrapper around a container. When I say a pod, it actually means it's a wrapper around a container. So you have your CoIT front-end container. Assume you are running the front-end container. So inside Kubernetes, there is no container concept. I mean, the smallest unit in Kubernetes is a pod. So this outer layer, what you see is a pod. It is just a wrapper, because Kubernetes is designed to work with the pods, not with the containers. When you want to do a communication, you want to talk to a container. Actually, no, it is the pod that get the IP address and stuff. Container don't get its own IP from Kubernetes. Kubernetes assign the IP address to the pod. So a pod is technically a wrapper around a container. Whatever communication you want to send to the container, you send. You will be talking to the IP address of the pod. Sorry, guys. You'll be talking to the IP address of the pod, and that's how it works. Pod is the smallest individual unit in Kubernetes, not the containers. Containers is inside a pod, and there can be more than one container inside a pod as well. But again, I'm not getting into that topic. For now, you guys just assume a pod is same as a container, right? Just assume that. Whether I use the word pod or container, assume it's the same, right? Assume it's the same. And I need 15 minutes more. Sorry for that. I need about 15 minutes more and to show you this thing. So now I want to create a pod inside the Kubernetes cluster. I want to create the CoIT front-end pod. Generally what you do is you will just search in Google pod Kubernetes. Then you will go to the documentation. You will get some sample YAML file. So I'm going to copy this sample YAML file onto my laptop. Just want to create a pod myself. So in my laptop, I already let me create a new folder. Not here. Mm-hmm. Let me create a new file in my laptop. Okay. So it's a YAML file that I am creating. So basically, I'm just creating a pod, and this is the syntax. You have to specify the API version, kind, and name. So this determine what is the kind of resource you are creating using kubectl. You will create it later, but what you are creating a pod. And this is the API version of Kubernetes. Kubernetes has lots of APIs. This is the particular API that support pod. So, and you are creating a pod. The name of the pod is Nginx, and then you have to specify. So, name of the pod I'm going to change to CoIT front, and name of the container I'm going to call it still CoIT front. Why not? And then over here I'm going to specify the container image that I want to use. So I already have a container image called CoIT learning / CoIT frontend v11, whatever image that I have kept inside my Docker hub. That is the image that I want to use. Container port is 80. Yes, it's Nginx, so it's 80. So that's what I'm going to do. I'm going to create a pod myself. And this is how you can create a pod yourself. And this is the file that I have just created inside my laptop, and it consists of the instructions to create a Kubernetes pod, and that's what I'm doing. So basically what this command does is it would create a pod, and you can run the command kubectl get pods to see the pod. So this is the pod that I have just created, and it is in running state right now. It is in running state. It's created. The pod got created. That's perfect. So you can create a individual pod yourself. So what you have to do, just like what you do in your laptop, every time you want to do something, you will do this. You will write a YAML file in your laptop, and then you will execute the kubectl apply command. Kubectl apply command you will run, and then so the kubectl apply command in our particular case indicate that I must create a pod. This is the name of the pod, and this is the image from which I want to create the container, and this is the container that will run inside the pod. And I told you container and pod are actually different, but for now we can assume they are same. So pod is actually a wrapper around a container. So I created a pod successfully inside my Kubernetes cluster. Now my Nginx application is running inside that container. Great. And now I'm going to delete this pod. Right. Now I'm going to delete this pod using the kubectl delete command. Delete pod followed by the name of the pod that I have just created. Right. Now the pod got deleted. So what will happen if I delete the pod? Will it get recreated? Actually, no. Currently, this pod is directly managed by me, not by a controller. Earlier, I talked about the decide state and the actual state. Remember the decide state? I can set the decide state with the kubectl, and then some controller that run inside the Kubernetes cluster will keep checking the decide state, and then make the modification to the actual state and bring it to the decide state. So there should be a controller who should be fixing such kind of things. But in this particular case, when I created a pod, there is no controller, right? There is no controller that I created. It is my responsibility to create a controller. I didn't create one. I just created a pod directly using the kubectl apply command. So then what happens is pod got deleted and nobody is there to recreate it, right? So that's why it's a bad idea to create a pod yourself. Instead, you should be creating a controller instead of creating the pod directly. In this particular case, a deployment controller. It's a deployment controller that you should be creating. What the deployment controller does is, now you create this controller in the Kubernetes cluster, and the controller will manage your pods rather than you directly managing it. So using the kubectl, so you would be writing a decide manifest about a controller that you want to create. So I'm going to create a Kubernetes deployment controller. And again, that is a YAML file. The YAML file which I have already shown you once. This is that particular YAML file, and you can see it. I'm creating a deployment this time, not a direct pod. So these three lines together defines what is the resource that I am creating. Deployment comes under this API. I already told you Kubernetes has many APIs. Something come under some APIs, so you can get that information from Google which API has deployment. So yeah, so this is the resource that I am creating. I'm creating a deployment. The name of the deployment is CoIT frontend. Great. And then I'm specifying replicas equal to 2. I want to create 2 pods. And then I'm going to specify what is the container image to use. I mentioned this is the image from which I want to create the container. So you can mention VL1 or whatever. Right? That's the image from which I want to create the container. And then this is the name of the pod. Over here I define the pod settings. So this is this definition is same as the pod definition what you have seen here, right? This definition, you can see the pod definition over here. This definition kind of look exactly same, right? Metadata and spec. Under metadata you mentioned the name of the pod. Under spec you mentioned the name and image of the container, right? So this is actually the pod settings, and this pod is managed by this deployment, right? Whatever pod it is, how many pod? 2 pods. Replicas equal to 2. So 2 pods get created. Each pod settings are written over here, and then it is managed by this particular deployment. So that is the thing. Okay, great. So let's see what will happen. I already have executed this file, right? Kubectl apply. I have already executed this file last time. CoIT front-end deployment.yaml. Basically, two ports get created over here. Kubectl get ports. Yeah, actually, it is restarting the containers because I changed the image name. Previously it was latest, now I changed it. So that's why it is restarting it. Okay, great. So now you can see two containers are running, and these containers are create. No, I did not create the containers directly. I did not create the ports. What did I do? I created a deployment resource, and the deployment has internally created, and it is currently managing these ports. And if somebody delete this port from the cluster, deployment will keep creating it, right? So basically a deployment is a controller. That is what I mean by a controller. Deployment is one type of controller in Kubernetes that will keep checking the decide state and then synchronize the actual decide state with the actual state. That's what it will do. What that means is, if I try to delete this pod, let me try to delete one of this pod, what will happen? If I delete the pod, then the actual state has changed, right? Whenever there's a change in the actual state, controller will do the action, whatever is necessary to bring the decide state to the actual state. So in this particular case, create an extra pod. Now it is taking time. Yeah, it's done. The pod got deleted. Now you can run the command get pods. Actually, 44 seconds ago, I initiated the delete command, and then a new container got created automatically, right? So the deployment automatically created the new pod when it noticed that one pod is missing. So that's what this deployment controller will do. It will keep checking the status and correct the problem if there is a problem. Great. Okay, now the next thing. So you'll be creating redeployment, one for the CoIT frontend and one for the CoIT backend and things like that. So because you want to run 3 of your applications, not only the frontend, you want to run the Java application, you want to run the Python application also. So I'm going to create total 3 controllers. 3 controllers. One is the CoIT frontend controller, the CoIT frontend deployment, CoIT backend deployment, CoIT backend 2 deployment. I'm going to create 2 other deployments also. Let me do that. And similar YAML file, exactly similar YAML files. And then this is the CoIT front-end deployment. I'm creating a deployment. This is the name of the deployment. And then replica is equal to 3. Then I'm specifying the port settings over here. So I want to create 3 ports, and these are the settings of the ports, the name of the port and the name of the container and the image from which it should be created and stuff like that. And similarly for the CoIT backend 2, again the same settings. I want to create 2 replicas, the Python application 2 replicas, and then over here I have the containers from which image it should be created, stuff like that. So great. So I'm going to create both Java and Python applications. So all I have to do is I can execute the command kubectl apply, and first I will do it for the CoIT Java YAML file, CoIT backend 1 deployment, and then similarly CoIT backend 2 deployment. So now I have created total 3 deployments, 3 controllers. And yes, you already know, in fact, what they will do, they will create the ports. So I think for the backend one, I mentioned 3 replicas to be created. For the backend 2, it's 2 replicas. And for the front end, it is 2 replicas. So that is the current state. So total 7 ports will start running inside my Kubernetes cluster. 7 containers are now running inside the cluster. Great. And that is the current state. You can run the command kubectl get ports to confirm. You can see, yes, there are 7, right? 3 backend ports, 2 Python ports are being created, front-end ports that are already there. So total 7 ports are now running inside my Kubernetes cluster. Now, the most important question, how they will speak to each other, how they will communicate. So all this software, they want to be communicated from outside, right? Somebody want, I mean, when I say, yeah. So the front end, the Java application, Python application, all the applications need to be communicated, right? And assume this is the front end application. The browser is, right? My customer is using their browser. They want to speak to this application, front end application. And then I have the Java application who want to speak to the Java application. Again, my customers who click on the send button on their browser, they want to speak. And then I have my Python application who will speak to the Python application. My Java container internally want to speak to the Python applications. Right? This is what I want. Okay, this is exactly what I want. And so how there are many containers whom it will communicate to, right? In case of Python, there are 2 containers. So which container Java will send the traffic to, or in case of a front end, there are 2 front end. So your customer browser want to speak to the front end, how it will speak to, or how it will speak to the Java applications. Actually, if you want to enable communication for your Kubernetes cluster, first of all, you should create a service. So you need to create a service, and a service sit in front of a container and send the communication to the container. Okay, that's what a service is. A service sit in front of the containers and then enable the communication coming. So anyone who want to speak to the service, they can to the container, they can actually speak to the service, and service will internally speak to one of the backend containers. Similarly, a service has to be created here, which will do the traffic to all the backend container, and a service has to get created here, which will distribute the traffic to the Python containers. So you want to create a number of services. So to enable the communication coming towards the application, you must create a service, and that is very, very important in Kubernetes. And then whoever want to speak, they will speak to the service, right? Your customer using their browser, they want to speak to. When somebody click the send button, they will speak to the Java service. When they browse first time, they will speak to the front-end service. So they will keep speaking to services, right? That's what they will do. They will keep speaking to various services. Great. So there should be a service that has to sit in front of your ports. Then I'm going to create a service. So I'm going to create 3 services: the Python service, the Java service, and the front-end service. 3 services I'm going to create. So the service is more like somebody said, some middleman, right, who will accept the traffic and forward the traffic to one of the containers, and it will also do some kind of load balancing, ensuring that the pod get the request correctly, things like that, right? So let's talk about services. Creating services. For now, I'm not worrying about my customers who is sitting outside the cluster. I'm just creating 3 services. Let me remove this line from here. So 3 services. Basically, this is the front end service. This is the front end service, and the front end service is basically, I'm just giving it some name. This is the API, and this is the name. This is I'm going to create a service. And I mentioned that it listen on port number 80, and it will forward the request to port number 80. And then the selector is CoIT front end. So basically, selector means what are the ports that it will speak to at the time of creating the service. The name of the service what you are creating is CoIT front end LB, or whatever name, CoIT front end LB. And then I'm also mentioning that this service will speak to those ports who has this label app equal to CoIT front end. Now what I have to do is, I go to the deployment YAML file, CoIT front end deployment YAML file, and then over here, actually, I have already created a label for the port, for the CoIT front end port. Under the port settings, I mentioned a label app equal to front end. Now I am telling my service that so every port created by my CoIT front end deployment, right, has this label. So this way, I had already labeled all my ports. This port has this label, this port has this label, and this port has this label. So when at the time of creating the deployment, I also specified the label to be set on each of these ports, right? And now when I am creating the service, I will tell the service that let's take a look at the front end service. For this service, I'm telling the service that, hey, talk to those ports who has this label. And that is how service and recognize which are the ports it should send the traffic to using the labels, which is a very cool and useful feature in Kubernetes. So that's how they speak to each other. Great. Sorry guys, I need 10 minutes more. Please don't mind. So this way I'm creating service, and that is the CoIT front end, and similarly CoIT backend also. It's listing on 80, sending traffic to 5000. Backend 1 listing on 80, sending traffic to 8080 for the Java application. So that's the point. So all the services are listening on port number 80 and sending the traffic to the respective backend. So in this particular case, it is 8080. In this particular case, it is 80, the Nginx port. In this particular case, it is 5000, the Python port. So, right, so that is the port it will forward. It listen on 80 only. All services listen on 80 only. So that's what mentioned. Service listen on 80, send the request to port 8080 or whatever the target port is. Now I'm going to apply the settings. kubectl apply -f service CoIT frontend. I'm creating the CoIT frontend service. I'm creating the CoIT backend 1 service, and I'm creating the backend 2 service also. So 3 services I have just created. Perfect. So now the service got created and they are sitting in front of my containers. And now anybody who want to speak to the application, they can speak to the service. Okay. From now, anyone who want to speak to the application, they can speak to the service. So that is what a service is. It is the communication point of your container. Great. And now people from the outside world, they want to speak to these services, and I'll talk about that. Okay guys, maybe we will wind up here. What I will do is I will record it and I will send to you. I think already too much information for now, but yeah, I will send you another video today. Let me show you, talk about something else now, right? So this cluster which I was working on so far, this cluster is a local cluster, a cluster that I have created in my laptop using K3D. So K3D is a software that if you install in your laptop, you can run a Kubernetes cluster in your laptop. okay, and how to install and set up K3D is demonstrated inside this course, basil.dorward.tech. You can find this module. You can see this course Kubernetes labs, and inside the Kubernetes labs, you can find setting up K3D cluster locally. Over here, these instructions will, you can set up yourself. You can build a Kubernetes cluster locally in your laptop. And now that's the local cluster. And so whether the cluster is local or remote, the working pattern is same. There is no change. It's exactly same way you will be working, whether it is local or remote, right? Always remember that. And let me now talk about a remote cluster. Right now, I already told you, maybe it's a surprise I didn't tell you so far, right? The cluster was actually local. And now let me create a cluster in the remote, right? In the AWS cloud, I'm going to create a cluster now. And inside this cluster, I want to replicate the same applications, right? That's what I'm going to do. And then let me do that. I already have a cluster in my AWS account. As a DevOps engineer, I have the ability to connect with more than one Kubernetes cluster at the same time. It could be a local cluster, it could be a cluster in the cloud. Now I have a cluster in the cloud. And I have a cluster in the cloud. And now from now, I'm going to ask my kubectl to start speaking to cluster in the cloud, this cluster right now, whichever I am working on. It is currently in the AWS cloud. So now my kubectl is speaking to the AWS cluster. So before I started this session today, I have already set up the AWS cluster. And then I connected kubectl to that cluster, so I can start running kubectl command from my laptop, and I can talk to the AWS. So what I'm going to do is I'm going to do all kind of deployment. So whatever I created in my local cluster, this whole thing I want to replicate inside the production cluster, and I would use the exact same YAML file. I won't change anything. I would use the exact same YAML file. So I want to create 3 services. Then I want to create 3 deployments. So I'm going to do that. That's what I'm going to do using the kubectl apply command. I'm going to create all the deployments one by one. First one is CoIT front-end deployment. And then the next one is CoIT backend 2 deployment. And then the next one is CoIT backend 1 deployment. There is no order. I can create it in any order. It's okay. And now I want to create the service. So I'm going to create the backend 2 service. First, I'm going to create the backend 2 service, and then I'm going to create the backend 1 service. And before creating the backend 1 service, let me make one tiny modifications here in the service YAML file. I'm going to add a line called type load balancer. Right? I'm going to add a line called type equal to load balancer. That is my Java application service where I mentioned type equal to load balancer. And similarly, I'm going to do the same thing for the front-end service also. And I will tell you why I did that, right? I just added this line type equal to load balancer. I just added that. So basically, what I am going to do here is that I'm going to create the services in here, and which is I use the same exact YAML file with one difference. For the CoIT backend one, the Java application and the front-end application, I mentioned that service type equal to load balancer. Technically, what I am trying to do here is that I'm going to ask my cloud provider to provision a load balancer with a public IP, and then configure the load balancer to send the traffic back to my service if any of my customer connected to those load balancers. Right now, anyone in the world, right, this load balancer have a public IP. Anyone in the world can browse for this load balancer URL, right? Not just my developer, but anyone in the world, right? Because it's public IP, anyone can browse. The request will come to the backend, and then the backend can send the request. Request will come to the load balancer, and the load balancer will send the request to the correct containers inside my Kubernetes cluster. So this is one best thing about Kubernetes. It integrate with your cloud provider very well. It will provision different resources in the cloud, such as load balancers. All you need to do is the only thing what I did is I changed the line type equal to load balancer. That is the only change which I made. Rest of the things Kubernetes takes care. My Kubernetes is capable to speak to my cloud provider. In my case, it's AWS, and provision a load balancer on behalf of me. So let's see. Let me run the command kubectl apply -f. So I'm going to create the backend one YAML file, and I am also going to create the front-end YAML file. And now I created the services. Now you run the command kubectl get ports. You can see all the ports, right? I have many other ports also. Grep point. I can see all the ports. I have 7 ports running. Now let me try to get services. I'll run the command get services. You can actually see all the 3 services. And one extra thing what you see is in the 4th column, you can see an external IP address. Right? This is a public IP. CoIT backend 1 got a public IP. CoIT frontend got a public IP. And anyone in the world, this is a public IP that anyone in the world can browse, and they will see this web page. You don't have to do the port forwarding. If it is a cloud cluster, there is no need of port forwarding. You can simply define the service as a load balancer, and then AWS will, or your cloud provider will automatically provision a load balancer for you. You would get a public IP that can be browsed by anyone in the world, right? So this simplify a lot of things from the networking perspective. Great. And I have a documentation. Don't create a cluster in the Google AWS. Create a cluster in the Google Cloud. Create yourself an account in Google Cloud, and then create a cluster in the Google Cloud, because Google Cloud provides some free tier. So try this service. So this is the same course, Kubernetes Labs. Second module is all about creating a Kubernetes cluster in the Google Cloud, and follow the serial number 1, 2, 3, 4. The order is wrong. So please follow the serial number. Start from the serial number 1, 2, 3, 4, like that. Okay. So do that. First you set up the K3 cluster correctly. Deploy everything. Use the same manifest to deploy the Google Cloud cluster. Before deploying the cluster, first you have to set up Google Cloud cluster. Create the cluster and connect from your laptop. So you can follow this documentation to create and connect to the GCP cluster. Great. So yeah, and be prepared for tomorrow. Tomorrow we are starting with our advanced training on AWS. Right? I'll just give a summary about day 5, which was a video lesson. So we discussed about now what is container orchestration. Container orchestration is basically Kubernetes. I mean, it's basically how you run your containers in production. So ideally, when you use Docker run command, you have 1 or 2 containers that you want to create. Docker run commands works fine, but when you have thousands of containers or 10,000s of containers for your project and you want to run them all inside, then you cannot use Docker run. It's not practical. So in order to do that, you need some container orchestration, well-managed container orchestration available. So you may be running containers, you may have 10,000 containers running across some 10,000 machines, or maybe, some 5,000 machines, or it doesn't matter, maybe 1,000 machines or 10,000 containers. That is also possible. So you want a way to manage them, and if the container goes down, it should be restarted. Your application crashed, a new container should be replaced it with. So Kubernetes does that automatically. Just just in case of any problem. You don't have to, in the earlier days, you have to keep watching your application. If it fails, you should restart it automatically using some script, using some tools. You don't have to do that. Kubernetes has that inbuilt mechanism to do that. Your container got killed, it gets created again automatically. So any node got deleted, any worker node in the cluster got deleted, automatically Kubernetes will move all the containers to the other nodes. So like that, Kubernetes has automatic recovery mechanism. So just in case something goes wrong with your application, Kubernetes automatically manage such kind of things. So that's why you need Kubernetes, or Kubernetes is a container orchestration tool. Kubernetes is not the only container orchestration tool. It's one of the tool, but that is, and now that is the only tool that has this much popularity, and most companies are using Kubernetes because it's awesome and it's open source, it's extendable. There are various reasons why Kubernetes is leading the market completely. So so we discussed about what is container orchestration and what is Kubernetes. Kubernetes is basically open source software. We discussed that. And the open source, when I say open source, it's free. The source code of Kubernetes is available to everyone. You can go to GitHub website and search for Kubernetes. You can get the complete code of Kubernetes, the code that the developers have developed in order to develop Kubernetes. You can get that code, you can modify the code, you can customize the Kubernetes based on your code. So it's open source, it's free, and also it is extendable. If your company want to use Kubernetes as it is, and then on top of it you want to add some additional feature, that is also possible. And then Kubernetes is a combination of number of software like API server, scheduler, and a lot of things, and it run inside a cluster. So the cluster consists of manager nodes and it consists of worker nodes, and minimum there should be 3 nodes. Even 1 node also Kubernetes can run, not a problem, but recommended is 3 nodes. So Kubernetes is not a single machine, it is a number of machine working together, right? And then it has various softwares, managemental and otherwise. Various softwares are installed across various nodes. At the end, all these nodes work together as a single cluster. So that is what Kubernetes is all about. And then we have seen what are the various components of Kubernetes. Various components of Kubernetes. It can consist of API server, the most important part. It consists of the API server. Then it consists of a scheduler. API server is the one who receive the connections from kubectl. From a DevOps engineer, you want to talk to Kubernetes cluster, you speak to the API server using kubectl. Or not only kubectl, there are various commands today available, or there are various tools available today which can talk to your Kubernetes API server and communicate to the API server. Ask the API server to do this, or download something from the API server, or get some data from the API server. So there are many tools available today. kubectl is the default tool that everyone uses, that is from Kubernetes directly, and using kubectl, a DevOps engineer, or it does not has to be DevOps engineer. Sometimes it can be various systems in your company that can run the kubectl command to talk to a Kubernetes cluster, get some data, or apply some changes. Right? All these things can be done. So for that, there's an API server, and then there's a scheduler, controller manager. Various components are available, and all these components, they run inside the Kubernetes cluster. They run inside control plane to manage the machines, and there are control plane components, and then there are worker components also. There are some software that run inside the worker machines instead of control plane. That is Kubelet, Proxy. These are the software that run on the worker nodes. Every worker node they run, and they will check the status of the worker node. They will check how many containers are running, and they will keep sending this information to the API server. So Kubernetes get to know about each and every worker node because of that agent software that is running in each worker node. So we discussed about various components in the control plane, various components in the worker nodes that we discussed. And then what else? We also talked about deploying the applications, how deploying applications. So how a DevOps engineer deploy application to Kubernetes. So in order to deploy applications, like I said, Kubernetes has internal mechanisms to maintain and manage your application. And what you have to do is you have to write down the code, you have to write down the instructions for Kubernetes, which container image that you want to use, how many replica that you want to run, right? All this information, you will put them together inside files, and then you will be submitting these files to Kubernetes API server, and then Kubernetes API server will take this YAML file, whatever you submitted, and then it will understand the decide state. Decide state means the state which is set by you, a DevOps engineer or a DevOps team who wrote the YAML file, and that is the decide state. So Kubernetes API server will read this decide state, and then it will make sure that it changes the actual state of the cluster to satisfy the new state. So for example, you try to set 3 as the replica, that become the decide state, and then what Kubernetes does is Kubernetes will create 3 replicas. Or Kubernetes is already running 3 replicas and you change the number of replicas to 4. Then you are submitting this file again. Then Kubernetes will again check, the actual state. Right now it is 3 replica, but you change the YAML file to 4 and you again run the kubectl apply. So you change the decide state. Then Kubernetes will again check that, okay, total number of replicas is 4 and right now it is 3. Then Kubernetes will create a new container and that would make the total number of containers 4. So that way, Kubernetes technically manage most of the things, right? So you have to just specify the decide state of your application and submit that YAML file to Kubernetes, and Kubernetes will do the rest. That is how you deploy applications. You don't have to make manual changes or application restarts. None of these things are manual. Kubernetes does all these things in an automated way. And that is one thing. And then we have seen what is a pod. Pod is basically, for now you can assume pod is nothing but a container, but optionally pod can have more than one container. So when you have your software applications such as CoIT frontend, CoIT backend, or shopping cart, prime customer, whatever software application that you have, due to some application requirement, in rare cases you may have to run more than one containers in the same pod, or maybe most of the time you will be running only one container in one pod. But whatever the case is, Kubernetes recognize pod as the smallest application unit, right? So what that means is, when Kubernetes want to allocate some resources to your application, it considers pod as the smallest unit. So it would allocate networking, it would give IP address to the pod, it would give volume data storage devices. When your container want to store some important data, those data storage devices are given to the pod. And like that, it is the pod that Kubernetes has as the smallest unit. So yes, pod is nothing but it's just a wrapper around the containers. The point what I'm trying to make here is that whatever resource allocated to pod, container would internally use it. And yes, at the end it is your application, but the way how Kubernetes is designed, it is designed for pod to be the smallest units. So whenever you want to allocate some volume, IP address, networking settings, you would be doing that to the pod, and your containers internally uses that. And if there's only one container per pod, most of the time you can assume pod to be nothing but a container. Pod is just a wrapper around a container, that's it. So most of the time I would be using the term pod Pod is nothing, so they are actually not same. Container is what you run your application, but pod is just a wrapper to keep them everything in proper shape. And then we discussed about services. What is a service? So when you have a fixed number of pod running, then they want to, your application want to receive some incoming request. So you are running CoIT front-end application. Inside 3 pods, assume you created 3 replicas. So 3 pods got created, and all the 3 pods that got created, they are running your CoIT front-end containers. And now these pods want to receive communication from outside. So in such case, which pod, if there are 3 pod, which pod the communication will come, right? There's a confusion in doing that. So that is why you should create a service. Every time in Kubernetes you want to expose your application, you should be creating a service. You want to receive incoming traffic, first you should create a service. Service will sit in front of the pod. It will receive the communication and forward the communication to the backend containers, backend pods. That's what services will do. So always the services would be sitting in front of the pods, accepting the traffic and forwarding the traffic back to any one of the pods in the backend. And deployments create pods, right? So when you want to create a deployment in Kubernetes, that is where you write down the instruction. Deployment is a controller which has the capability to keep checking the decide state and then correct the actual state. That's what a deployment controller will do. So inside the deployment controller, you can specify how many pod you want to create and from which image that you want to create it, right? All these things we discussed. And then you don't create pod directly inside Kubernetes cluster. You always create deployment, and then only every time you run the kubectl command, Kubernetes will automatically check the current status, and then it changes to the decide state. It will make, it will check the decide state and it may changes the current state. So Kubernetes has to do that if it is a controller, right? If you create a pod directly in Kubernetes, Kubernetes won't manage it. So that is why it is very important every time you want to create a pod, do not create the pod directly. You should be instead creating a deployment controller. Once you created a deployment will manage all your pods. Create the pods. If any pod ever got failed, it will restart it or recreate it. Or if, right? So deployment, once it is created, then you set the decide state of your system. Then rest of the things Kubernetes will take care of. Restarting the container, creating new container if one got deleted, all these things Kubernetes will take care. You don't have to worry about that part. So that's what you have seen. And then we have seen 2 different type of clusters. One is the K3D cluster and the other one is the Google Cloud Cluster we have seen. So K3D is mandatory that you all should create. Google Cloud Cluster is optional, but yeah, just try to create it. It's interesting. It's very interesting actually. So make sure that you know. Also, the most important good thing is that whatever manifest what you have written, same manifest can be reused for whatever cluster that you are using. Whether you are using K3D, whether you are using Google Cloud Cluster. In Kubernetes cluster, you can create in the AWS Cloud also, Microsoft Azure Cloud. There are a lot of cloud providers, and all these cloud providers provide managed Kubernetes service. So what that means is you can create a Kubernetes cluster in the cloud, and then once the cluster is created in the cloud, you can configure, it is not as straightforward as K3D, but every cloud provider allow you to talk to the Kubernetes cluster that you created in the cloud using kubectl. Just like kubectl speak to your K3D local cluster, kubectl can also speak to the cluster that is sitting in the cloud. It could be Google Cloud, it could be AWS Cloud, whichever your cloud computing provider is. Once you created the cluster, cloud provider provide you set of instructions on how your kubectl can speak to that cluster. And once that is done, you can just manage your application just like how you manage K3D, right? Your deployment YAML file, service YAML file or whatever YAML files that works for K3D, same YAML file works for Google Cloud also, because it's the same software, it's the same Kubernetes software that everyone is using. K3D is using same. K3D is not using exactly same actually. K3D make a lot of from the original Kubernetes K3D. The people who developed K3D, right? They took the original Kubernetes code and they removed whatever feature that are not very critical. They removed it and they made it very lightweight. So K3D technically don't have all the feature that a real Kubernetes cluster have, but it has every feature that you normally need, right? That's why K3D will work for most cases. You don't have to worry. And Google Cloud Cluster or Kubernetes cluster that you create in cloud providers, they will have additional capabilities such as load balancer creation, cloud network creation, and a lot of possibilities of networking. A lot of customization on networking may be done. A lot of security settings may be applied. If you want storage devices, it may be created and mounted. So when we are using a cluster in the cloud, generally, again, it's Kubernetes software, but they have added a lot of extra features. Every cloud provider will so Kubernetes is open source, right? Since Kubernetes is open source, anyone can get the Kubernetes code and change Kubernetes the way they want, and that is what Ranger had done. Ranger is the company who built K3D, and then or you can download Kubernetes as it is, and then you can set up your own cluster, right? It's not only in the cloud that you can create a Kubernetes cluster. Any company decide that they want to create and manage their own on-premise clusters, that is also possible. Kubernetes supports that. So these are maybe I'll just draw this up, right? Various clustering options, right? Just let me clarify that one.